Before we move on in Unit 1, we have to review some exponent rules, some things that you probably learned back in Algebra 1. This is a very short set of notes because we're going to continue this on in Lesson 7.1 and 7.2. So first of all, we have some properties of exponents that we need to have memorized and know how to use. And you don't need to know the names of them, but you do need to know how they work. So the first property is the product of powers. And it says that if you multiply a common base together, so in the generic case a and a, what you're supposed to do is add the exponents together. So when I look at x to the 5th times x to the 6th, if I add those together, I get x to the 11th. Now when you have a power of a power, so a power taken to another power, the property says you're supposed to multiply those numbers together. So x to the 5th to the 6th power becomes x to the 30th power. And then if you have a product inside parentheses and an exponent outside of it, you could distribute the exponent to both of the monomial bases. So this works like xy to the 3rd becomes x to the 3rd and y to the 3rd. Now when you have a negative exponent, that means that that particular base is on the wrong side of the fraction. So if he's in the numerator, we're going to flip that base to the denominator, and if he's in the denominator, we're going to flip that base to the numerator. So when I look at the first example, x to the negative 1, there's an invisible fraction bar here with an invisible 1 underneath. So what you're going to have to do is think about taking this base of x and flipping him to the bottom. So this becomes, there's nothing left up top, so we could put a 1 as a placeholder, and then x to the 1st on bottom. Now for the second example, y to the negative 1st is in the denominator, so because he's negative, we're going to flip him back up to the top, and that's what's going to make this positive. So the answer is y to the 1st, or just y. If you put over 1, that's fine, it's just not necessary. Now anything to the 0 power is a 1, so it doesn't matter what the base is, if it's taken to the 0 power, the answer is a 1. The quotient of powers says that if we have a division problem where we have a common base, in this case a, the way that we calculate their new exponent is we subtract the numerator's exponent minus the denominator's exponent. So for x to the 8th over x to the 5th, 8 minus 5 is 3, so your answer is x to the 3rd. Now when you do the next example, 4 minus 7 gives you a negative 3. But from two properties ago, we realized that we can't have a negative exponent. So we're going to have to actually end up taking this base of b and flipping them to the denominator. So that way we have a positive exponent. So there's nothing left up top, we're going to put a 1, and then we end up with b to the 3rd in the denominator. And then if you have a division problem, which is a quotient, with an exponent outside of it, you can distribute that exponent to both the numerator and the denominator. So for our example, we can change that to say x to the 4th divided by y to the 4th. Now all of these properties can be used in reverse if the case comes up, but usually we go in the order in which we showed. So some examples here, and they're all mixed together, different properties. The first problem is the quotient of powers. So the rule says we're supposed to subtract the exponent, so this becomes x to the 7th power. Now when I look at the next example, I can only combine the like bases. So I'm going to combine my x's together using the product of powers property, and I'm going to do the same thing with the y's. So with my x's, x to the 4th times x to the 5th becomes x to the 9th, because we're adding those exponents together. And then y to the negative 1 times y to the 8 becomes y to the 7th, because again we added those exponents together. Everybody's positive for the exponents, so we are done. The next property is the power of a product property. So we're going to take this 3rd power and we're going to distribute it to both the x and the y squared. So that becomes x to the 3rd. And then y squared to the 3rd power, we're supposed to multiply those exponents together and we get y to the 6th. We're going to do something similar on the next example. Everybody's going to get squared. So we're going to say this is really, I'm going to first write it as 3 squared, and then x to the 6th, and then y to the negative 4. We multiplied the power to the power. Now a couple things we need to change. 3 squared is really a 9. And the other thing I notice is that the y to the negative 4 is a negative exponent, so we're going to have to flip him to the denominator. So my final answer is going to be a 9x to the 6th in the numerator, and then a y to the 4th down in the denominator. And that's how I want to see your answer. Okay, a couple more examples. We have the quotient of powers property here on the next example, and you can only do this property with like bases. So when I have x to the fourth over x to the negative 3, and I subtract them, 4 minus a negative 3 gives me a 7, and then 3 minus 0 will give me a y to the third. Now everybody by default goes into the numerator when you subtract them, and nobody's negative, so we're just going to leave our answer like that. Now be careful on the next example. The 25 and the 5 are really coefficients. You don't subtract them, you just divide them like you were in 5th grade. So 25 divided by 5 gives us a new coefficient of 5. For my x's, I have 7 minus a negative 1. Careful, that's an 8. And then y squared over y to the second. 8 minus 2 gives me y to the 6th. Okay, the next example, 12 over 8. If I reduce that fraction, you can either do math enter on your calculator or just think about dividing them both by a common factor of 4. You end up with 3 halves. So my coefficient is 3 halves. Now when I subtract the exponents, negative 5 minus 6 is a negative 11. At first I'm going to write him up top, but maybe you already know where to put it to fix that. And then y to the 7th over y to the 4th is a y to the 3rd. So the only thing I'm going to have to change here is this x to the negative 11th is negative exponent, so he's going to have to flip to the bottom. So my final answer is 3y to the 3rd up top, and then 2x to the positive 11th on bottom. And that's your final answer. Okay, the next example, we're going to distribute that negative 3rd power. So we've got 2 to the negative 3rd, x to the negative 3rd, and then y to the negative 6th. Now everybody has a negative exponent, which means everybody's going to flip to the other side of the fraction. So this x and the 2 are going to flip. This y is going to come up here. So we end up with y to the 6th up top. Instead of 2 to the 3rd on the bottom, 2 to the 3rd is really the number 8. And then x to the 3rd. And that's your final answer for that example. And now for the last row, some pretty basic problems. X to the 3rd times x to the 5th. The rule is you just add them together. So that's x to the 8th. X to the 4th times x to the negative 8. That gives us, when I add those together, x to the negative 4. But we know we can't leave that answer with a negative exponent. We're going to have to take this x to the negative 4 and flip them to the bottom. Okay. The next example, power on top of a power, we're supposed to multiply those, so it's x to the 24th. And then the last example, we're going to start with 3 to the 3rd, x to the 6th. And the only thing I'd like you to change there, instead of saying 3 to the 3rd, that's really a 27 x to the 6th. And that concludes the review on exponents.